So using square wave analysis, we can quickly determine the frequency response of our amplifier. Today I want to take a look at the high frequency cutoff formula and derive it from a couple of formulas that we should already be very familiar with. Here is the square wave analysis frequency high cutoff formula, 0.35 divided by rise time. And we're going to derive that formula from the capacitive reactance formula and the voltage charge formula for a capacitor. Knowing that at cutoff, the resistance that the capacitor sees should be equal to the reactance of that capacitor, or capacitance, or circuit capacitance. So we can manipulate the X sub C formula to equal frequency cutoff is now equal to 1 divided by 2 pi of that resistance times that capacitance. In this slide, we're defining rise time, and we're showing what rise time is. It's measured from the 10% to the 90% voltage marks. The y-axis is voltage, and the x-axis is time. Now let's take our capacitive charge formula and put the entire formula in terms of rise time. So we know that the VC should be equal to, if we're doing the rise time, 0.9 of V final, or 90% of V final. V initial should be 10% of V final. Time is now our rise time. Therefore, our formula should look like 0.9 of V final is equal to V final minus the quantity of V final minus 0.1 V final e to the negative rise time divided by RC. So here's all the algebra that goes along with simplifying this equation now that we have it in terms of rise time. The one step we should probably stop and take a look at is about halfway down we've got the 1 over 9 is equal to E raised to the negative rise time over RC. Now to get rid of the E and get rise time and RC by itself, you take the natural log of the entire equation, and then that gives us the next line. Natural log of 1 over 9 is equal to negative rise time divided by RC. And the final equation on this page is RC is equal to rise time divided by 2.19722. We left it. You could put that expression in terms of rise time. Might make sense to solve that in terms of rise time at this stage. But you'll see on the next slide why I'm leaving it as RC is equal to rise time divided by 2.19722. Okay, so we've broken it down in everything in terms of rise time and frequency cutoff. And we've got two basic formulas. RC is equal to rise time divided by 2.19722. And frequency cutoff high should be equal to 1 divided by 2 pi RC. And so we're going to combine these two formulas. We're going to, in the frequency cutoff formula, we're going to substitute in the rise time divided by 2.19772. And you can see that simplifies. If we take the 2.19772 divided by 2 pi, that gives us the 0.349778 divided by rise time, or 0.35 divided by rise time. And that's where our frequency cutoff high square wave analysis formula of 0.35 divided by rise time comes from.